Welcome to this video with me, Duncan Williamson, in which I'm going to demonstrate how to create this correlation matrix automatically. Let's look at the traditional way using the data analysis toolpack for this set of data. Are you ready? Data analysis, correlation, click OK. All I want to know is the input range for this range of data. I've included the headers, so labels in first row, and my output is this cell here. So providing there's nothing wrong with this input data, no data or anything like that, click OK, and we get that. It's a simple correlation matrix. All you have to do is, because it gives you millions of decimal places, just go onto the home ribbon, and I tend to set it to 4 decimal places. Piece of cake. We now know that the number of wells is correlated pretty well with the depth, 0.67, almost not at all with fuel costs, essentially 0. Over here, the depth is highly correlated with ton kilometer, and the weight is very highly correlated with ton kilometers. All right, that's it. That's what I wanted. That's what I've got. Trouble is, let's imagine, for the sake of argument, the number of wells changes. Let's make it an extreme change. Nothing happened to that correlation matrix. Did you see that? Nothing happened. That's not good. Here's my method for creating a correlation matrix in the piece of cake manner without fail. Okay, let's try that. Well, I've done it already, but let me explain how I did it. If you scroll back a little bit in this video, you'll see that two things. Number one, the answers I've now got are the same as what I had before, and there's one difference. A correlation matrix typically is in this bottom left-hand triangle configuration, and you don't normally see all of these. If you do, it doesn't matter, because all that's happened is this number is repeated here, this number is repeated here, this number repeated here, and that's why the correlation matrix is often bottom left triangle, top right triangle, not normally both. The only reason it's there is just a little bit of effort to rid myself of that top right hand triangle, and I don't need to expend such effort. So how does it work? The key to this solution is A, B, C to F, which is these letters here, and A, B, C, D, F, it's the same letters transposed. If my input data was in columns G, H, and I, it would be G, H, I, etc., G, H, I, etc. Second, down here, I've got number 4. That represents row 4, the start of the data, and the number 43 represents the end of the data in row 43. It looks a little bit frightening, but it's the correlation function wrapped around two indirect functions. Now, I know that in real life, with a big and busy model or spreadsheet, you wouldn't use the indirect function because it's volatile and it can slow your system right down. In this example, it's a small model. What you see is what you get. And for this correlation matrix, again, what you see is 6 rows, 6 columns. No one dies when you do that. But here's how it works. The indirect function allows me to build an address from A4, A43, and so on in this way. Indirect, open bracket, $3, $3, ampersand, concatenate, $K, $11, which is this one. So now I can show you that this gives me the first half of the address in the indirect on the left-hand side of A4. I then go to concatenate, these colon that separates an arranged address, and concatenate again, $K, $3, ampersand, $K, $12. That represents the second half of the address, A43. So we're building the entire address for this cell in the correlation matrix to return the correlation coefficient of number of wells against number of wells. We already anticipate the answer should be 1. Indirect, $I5, ampersand, $K, $11. It's going to say A4. Ampersand, colon, ampersand, $I5, $K, $12. It's going to say A43. Let's see if I'm right. Should we reveal the whole address? Can we do all of that? There it is. Ergo, I've now built the address for this cell, and the answer is indeed 1. And because of all the dollars I put in the address, I really can now copy that down and copy that across. And it shows all the decimal places to prove that I've just done that. And if you just step back a little bit, you'll see that I did indeed set out this correlation matrix properly. That is how to automate a correlation matrix. And when I change my input data now, let's do the extreme change over here. Watch what happens. Anything that's correlated to number of wells in this schedule has changed, updated. Everything, every aspect of that correlation matrix updates real time. Thank you for watching. It's a hot tip.